Hey, it's Mr. Harper Smith here. So last week we were talking about graphing systems of linear equations. So we would have two lines and where they cross would be the solution. Well, this week we're going to be working with a different method. Instead of graphing to find that point, we're going to use something called elimination. Elimination is one of my favorites. It's kind of like going into a paintball match. If you've ever gone to a paintball match and you're kind of shooting each other, last man standing wins. That's how elimination works, but you're eliminating either the x's or you're eliminating the y's. You get to choose which one you want to eliminate. So let's give it a try. Here we go. Here are two example problems. Let's start with this one on the left. So we have two equations. We have the equation negative 5x minus 6y equals negative 32, and we have 4x minus 6y equals 4. We want to figure out where do these two graphs intersect. Well, here's how we go. What I'm going to do is I'm going to either eliminate my y's or eliminate my x's. How I do that is by either adding or subtracting the two equations together. If you think about anything, you can add two things together. These are just two equations, so they're going to give us a new equation. So when I'm looking at this, I need to think, am I going to eliminate the x's or the y's? If we look, the x's are different. So if I add or subtract negative 5 plus 4 or negative 5 minus 4, it's not going to give me 0. It's not going to eliminate the x's. However, if I subtract negative 6y minus negative 6y, what's something minus itself? It's 0. So if I subtract these two equations, negative 6 minus negative 6, that gives me 0y. There's no y's left. Negative 5x minus 4x gives me negative 9x. Negative 32 minus 4 gives me negative 36. Okay? So all of a sudden I have a new equation without y's in it. So I take this negative 9x equals negative 36. If I want to solve, the opposite of multiplying is dividing. So I'm going to divide both sides by negative 9. That gives me x equals 4. So the x value where these two lines intersect is positive 4. All I need to do now is take that 4, plug it back into one of these equations to figure out y. So let's take 4 and plug it into this bottom equation. That gives me 4 times 4 minus 6y equals 4. Well, what's 4 times 4? That's 16. So I'm going to subtract 16 from both sides. That gives me negative 6y equals negative 12. If I want to get down y by itself, and divide by negative 6, it gives me y equals positive 2. So my answer here is, 4, 2. That is the point where these two lines intersect. Let's try another one. Here we go. I'm looking, am I going to eliminate my x's or my y's? Well, looks like the x's are the same, so I'm going to try to eliminate the x's. Do I need to add these two equations together, or do I need to subtract them? They're the same. If they're the same, and we add them together, that's not going to get me to 0. But if I subtract negative 8 minus negative 8, that would be 0. That would work. So negative 8 minus negative 8, that's 0. 5 minus 4 is 1, equals 43 minus 36 gives me, what would that be? 7? Yeah, that's 7. So y equals 7. Okay. Here we go. Let's try these two. I'm going to do this one. I'm going to let you do this one on your own. Okay. Here we go. So first I'm going to look, are my x's the same or are the y's the same? In this case, it's my y's that are the same. Now, are the y's the same? Are they both positive? Is one positive, the other negative? So are they the same sign or are the signs different? Well, in this case, it looks like they are different. So if I subtract them, 2 minus negative 2, that's 2 plus 2, which gives me 4 y's. I don't want 4 y's, I want 0 y's. So right here I need to add, because 2 plus negative 2 is 0. So let's maybe write that down as a rule. If the signs are different signs, that's signs, that's a different math term. the signs are different, we add. If they are the same sign, we subtract. Okay? So over here we're going to add everything on the equations together. Negative 10 plus negative 2 is negative 12x. 2 plus negative 2 is 0, equals negative 32 plus negative 16. That gives me negative 48. Divide both sides by negative 12. I get x is positive 4. All right, now I take that x. Remember, the system of equations, we need a point. We need the x value and the y value. So I've got my x, I take this x, I plug it in to get my y value. So that's negative 2 times 4 minus 2y equals negative 16. We add 8 to both sides. Because this is negative 8. How do I get rid of a negative 8? I have to add 8. That leaves me with negative 2y equals negative 8. Divide both sides by negative 2. That gives me y equals negative 4. So my answer here would be 4, comma, negative 4. Okay, that is my point. All right, I want you to try this one. Do that one on your own. Pause the video. You think you've got the answer? Unpause it and see if you got it right. Okay, you should have your answer by now. Here's the answer. So we've got the same y values. They're both positive. Ooh, so the sign's the same. That means I need to subtract. Since they're the same sign, they're both positive, I subtract. That gives me negative 15x equals 15. Divide both sides by negative 15. That gives me x equals negative 1. That is my x value for this equation. I take that, I plug it back in. Let's plug it into this top one. Negative 5 times negative 1 plus 7y equals 40. Let's see, that's going to give me positive 5. How do I get rid of a positive 5? I subtract 5. So 7y equals 35. Divide both sides by 7. Gives me y equals 5. So my answer here is negative 1, comma, 5. If you have further questions, ask your math teacher. They will be more than happy to help you. Make sure that you have your notes handy from this video if you do have further questions. The time is yours. Good luck.